Creating moving platforms in my game should be easy, right? I mean, Godot already has a built-in node specific for player characters that you control that react to physics objects, such as moving platforms. Well, for my Frogger-inspired game called Hopper, I actually chose not to use any of these built-in nodes, and instead chose to build my grid-based player controller from scratch. So I can't use any helpful methods built into the engine like move and slide to help move my player. Instead, I have to implement that logic myself. Last video, I showed you guys how I got my player set up with a state machine, so now it can perform basic movements such as idling, moving, jumping, and falling, and it also responds correctly to its environment, such as going up slopes. In this video, I'm going to show you all how I was able to recreate the classic Frogger level in my game by creating my own custom node that extends from Godot's built-in Path3D node that I call EntityPath. I'll also show you all how I got my player to recognize moving platforms and move and rotate with them. So without further ado, let's get into the video. When I first started this project, I had an absolutely terrible way of moving things across a path. This scene would move cars from a start point to an end point, and then once they reached the end point, they would be teleported back to the start point. The biggest problem with this scene is that I'm only moving the cars in the X direction, and they can also not turn. So this doesn't really lend itself to being a very flexible system. So really early on, I knew this had to change. My first attempt to fix this was by using the car path scene. This was a huge step in the right direction because I started using the Path3D node. In case you don't know, the Path3D node lets you create curves in 3D space, which you can add another node called PathFollow3D to, and you can use script to move that node along the curve. I won't go too far into the weeds about the Path3D node because I already did that in the last video, and plus there are plenty of great tutorials out there, and I'll link the one that I followed in the description. But the basic idea is very similar to the CarLane that I just showed you. But instead of just adding a car to the scene, we also add a PathFollow3D node to the scene, and then add our car as a child of that PathFollow. I followed this logic for all three objects that we needed to recreate the classic level from Frogger: the cars, the turtles, and the logs. But then I thought, wouldn't it be nice to have a generic class that I could add just any object to? This is where my current implementation comes in, which is the entity path. The first thing we do is we declare a bunch of export variables, which allows us to customize our scene. Most of these are self-explanatory, but I'll explain the more interesting ones. I have a couple enums that I declared at the beginning of the script, one of them being activation mode. I have three different ways that a path can be activated. Either it's active immediately, or it's activated with a timer, or with a trigger. And we use this variable to set our current state once the level starts. Movement type is another enum that we declared at the beginning of the script, and this tells our PathFollow3D nodes how to move along the path. So far, I've found that there's three different movement types. The first one being ping pong, which is where our entities bounce from endpoint to endpoint indefinitely. Our second one is loop, which is where our entities go around a closed path over and over again. And the last one is wrap. This is what we use when we want things to go from the endpoint and immediately teleport back to the start point, which is what we use in our classic level. We have a variable called entity groups, which is an array of integers. So for example, I could set up an array that was 2, 2, 2, and what that would mean is that I have three groups, all containing two entities in them. When we're creating our groups, we want to use that entity groups array and loop through it. So for this example, we're going to be looping through it 6 times. Creating the entities along the path is all the same, but the only thing that changes is where we place it on the path, where we use the index of the array and its spacing to find its place. Every entity that we instantiate, we add it to an array so we can easily access it and change its position during the process function. We also have a group start variable that we change every time we move through the array. This makes sure that the spacing of the group is the same, even if we have different numbered entities in the group. So if we have 3, 2, and 3, the spacing between the groups would all be the same. Last thing I want to talk about is our really simple state machine. All we have is 2 states, idle and moving. In idle, we want to make sure our entities are not moving. And if we set a value for the idle timer that's greater than 0 seconds, then we start that timer. And once that timer stops, we switch to the moving state. The moving state's also really simple. All we're doing is we're moving our entities across the path based on our speed. But if our movement type is ping pong, we want to reverse our direction once our entity reaches the ends of our path. Now, I have to come clean with you guys really quick. This class works for everything except for logs. The reason for this is because each segment that we instantiate onto this path acts individually. This is a problem for logs because when it turns a corner, I want that log to act as one unit. If I were to use this scene for logs, each segment would break apart from one another and it would look like one of those wooden snakes that you get, I don't know, when you're a kid, or one of those 3D printed slop dragons. And we don't want that. So instead of making this class super bloated and have it also build logs for us, I chose to create a new class called LogPath that inherits from EntityPath. Whoa, 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 whoa. I hear you guys. I hear your keyboards right now. They're starting to type very angry comments, but I actually wanted to do kind of like an experiment. I haven't really inherited one of my own classes before, so I wanted to do this as a little exercise just to see what it could do. One thing I wanted to see was if my process function that I declared in my base class would also run in this inherited class, which it does, which I thought was really cool. And I also wanted to see if we can override functions. So I overrode my create groups function from my EntityPath class to my LogPath class. The difference with this function is that we only have one loop for the array and instead use the integers that are in that array to build our log segments. This class is actually really cool because it builds log segments to however long we want them. So we have preloaded scenes for our log start, our log middle, and our log end, and we just build our logs based on how many segments we have in that entity groups array that we talked about before. So that's pretty much it for the entity path. These are great for moving things along a path, such as cars and moving platforms. But now I want to show you guys how we actually get our player to recognize these moving platforms and move along with them. Getting our player to move on these moving platforms all starts with the rideable component. This is a class that I made that basically just keeps track of its own change in position and change in rotation, which I call velocity and angular velocity. So when I'm building a scene that functions as a moving platform, I start with the path follow 3D as the scene root, and then attached to that is an animatable body 3D node, which basically serves as like the root of whatever's moving. So if I'm looking at our turtle scene, our animatable body 3D node is the turtle scene, and attached to that are the meshes, the collision shapes, and the rideable component. One thing that we do in our rideable component script is we get access to its parent, which is usually going to be an animatable body 3D node. And what we do is we turn off sync to physics. One weird thing that happens when you try to move an animatable body over a path is if sync to physics is on, the collision shape will be left behind. It won't move with the animatable body. So turning that off prevents that error from happening. That's one of the big reasons why everything relating to movement has been in process and not physics process. If we want our moving platforms to be updating on process, then I also want my player to be updating on process as well. So now that our rideable component is attached to our moving platform scene, now it's keeping track of its position or its velocity and its angular velocity. So how could our player get access to these rideable components and adjust its own velocity and angular velocity based on these values? Well, if you watched last video, I think you guys know the answer. It's the ground detector. I added a variable called current platform to our player script, and once our ground detector moves, it's going to ask if what it's intersecting is a moving platform, and if it is, it's going to update our player's current platform. So now our player has a reference to our current platform, which is always going to be a rideable component. So we can safely get access to the rideable component's velocity and angular velocity and use that to adjust the player's angular velocity and velocity. So that's basically it for getting our player to move along with these moving platforms. However, there's a little bit more we have to do in terms of our player's movement. In Frogger He's Back, which is the game I'm taking inspiration from to make my game, Frogger can actually move diagonally to find the center of a tile. Doing this makes movement a lot more fluid and intentional, instead of Frogger just moving forward and saying, oh, there's a platform underneath me now, I need to get to the center of this platform, so I'm just going to move my position that way. I was able to achieve this in Hopper by refactoring my move script to using a path like my jump path instead of a tween system. I did this because unlike tweens, we can actually clear all the points to our path nodes and add new points every frame. So as this platform is moving to the left or to the right, we can change our player's target position to be the new position of our moving platform's origin. So that's how we can get our player to move diagonally and sort of home in on these moving platform centers. But there's one edge case that really stumped me for this. There's a case where our ground detector doesn't detect any moving platform in our way, but while we're moving forward, it's possible that a moving platform can be underneath us as we finish our move. So now our player has no idea that there's a moving platform underneath it, so it's just sitting still and floating there. So how did I fix this? Lucky for me, I'm a super genius and when I was setting up state transitions last episode, there's a method called check context, which uses a downcast to see if we're floating in the air or if we're on solid ground. What I did was add another case to check if our ground is either a moving platform or normal ground. I did this by adding a new resource called ground data, which has an enum called ground type. Every time we finish a move and want to get information from our downcast, we call a method called getGroundData, which returns what kind of ground it's colliding with. If it's a moving platform, we check if we're in the center of it, and if it's not, we transition to a new state called stumble. What we do in Stumble is we just move the player to the center of the moving platform. I do this via the move path, so it could be argued that I don't need another state for this, but the reason I did that is because I probably want to play a different animation for this state. That was my reasoning for creating a new state. One executive decision I made was to not have the camera rotate with the player when it's on these platforms. Take this section in the second zone of Frogger He's Back, for example. When you're trying to maneuver over these turtles and your camera's constantly flipping 180 degrees, it gets nauseating and it's really hard to perform. So I just decided not to have the camera rotate when my player's on these moving platforms, and I think it works out pretty well. And on the topic of the camera, I want to know what you guys think of the camera smoothing that I added to my game. I'm honestly not a huge fan of it. I think it kind of reminds me of those SpongeBob AI videos. I don't know why, but that's just the vibe I get from it. I'm not a huge fan, but let me know what you guys think. And with that, I think we're pretty much done talking about moving platforms. So let's take a look at that classic level that I made, and we'll wrap the video up there. Since I plan on making my real levels in Blender, that's what I used to create this classic level, but I just as easily could have made this with Godot's CSG nodes and it would have worked just as well. I just wanted to see what the import process for levels was like with Blender. Once I got the level geometry into Godot, all I had to do was add 5 entity paths for the road lanes, and then 2 entity paths for the turtle lanes, and 3 log paths. And then once the paths are in, you have to assign a curve to each one, and in this case, they're all just straight lines. And then you just go into the inspector and adjust all the values. I think one thing I'd like to add for this is make it a tool script so that I can actually see what the lanes look like before I start the game, but that'll be something I add in the near future. And now that all of our paths are customized, we can jump into the level and see how it looks. And guys, I couldn't be more stoked about this level. This plays just like how it does on the PS1, and yeah, it just makes me super happy. And I know everything looks kind of scuffed, but I think this goes without saying, this is all placeholder art. My plan for the next devlog is to start implementing gameplay systems, so that would include collecting frogs, timers, and stuff along those lines, and then also try to create some nice looking levels for the first zone of my game. So yeah, hopefully in the next episode we'll have some overhauled art and some cool levels for you guys to check out. Now I'm super stoked about that. Hopefully you guys are as well. If you enjoy this devlog and want to follow along with the progress I'm making on Hopper, feel free to subscribe. Don't forget to like the video, and I will see you all in the next one. Peace.